In this video, I'm going to teach you how does a transaction get into the blockchain. This is part 2 of blockchain. Before a transaction is added to the blockchain, it must be authenticated and authorized. There are several key steps a transaction must follow through before it is added to the blockchain. Today, we are going to focus on authentication using cryptographic keys, authorization via proof of network, the role of mining, and the more recent adoption of proof of stake protocols in later blockchain networks. This is a diagrammatic representation of how does a transaction get into a blockchain. Authentication. The original blockchain was created or designed to operate without a central authority, but transactions still have to be authorized. This is done using cryptographic keys, a string of data like a password that identifies a user and gives access to their account or wallet or value on the system. Each user has their own private key and a public key that everyone can see. Using them both creates a secure digital identity to authenticate the user via digital signatures and to unlock the transaction they want to perform. Authorization. Once the transaction is agreed between the users, it needs to be approved or authorized before it is added to a block in the chain. For a public blockchain, the decision to add a transaction to the chain is made by consensus. This means that the majority of nodes or computers in the network must agree that the transaction is valid. People who own the computers in the network are incentivized to verify transactions through rewards. This process is known as proof of work. Proof of work. Proof of work requires the people who own the computers in the network to solve a complex mathematical problem to be able to add a block to the chain. Solving the problem is known as mining, and miners are usually rewarded for their work in cryptocurrency. But mining isn't easy. Mathematical problems can only be solved by trial and error, and the odds of solving the problem are about 1 in 5.9 trillion. It requires substantial computing power that uses considerable amounts of energy. This means that the rewards for undertaking the mining must outweigh the cost of the computers and the electricity cost of running them. As one computer alone would take years to find a solution to the mathematical problem, the power of mining. The power of mining. The Cambridge Bitcoin Electricity Consumption Index estimates the Bitcoin mining network consumes almost 70 terawatts power of electricity per year, ranking it the 40th largest consumer of electricity by country. By way of comparison, Ireland ran 68th, uses just over a third of Bitcoin's consumption, or 25 terawatt hours. And Austria at number 42 consumes 64.6 terawatt hours electricity per year, according to the 2016 data complied by the CIA. The problem with proof of work. To create economies of scale, miners often pool their resources together through companies that aggregate a large group of miners. These miners then share the rewards and fees offered by the blockchain network. As the blockchain grows, more computers join to try and solve the problem. The problem gets harder and the network gets bigger, theoretically distributing the chain further and making it even more difficult to sabotage or hack. In practice, though, mining power has become more concentrated in the hands of a few mining pools. These large organizations have the vast computing and electrical power now needed to maintain growth. A, a blockchain network based around proof of work validation. Proof of stake. Later blockchain networks have adopted proof of stake, validation consensus protocols, where participants must have a stake in the blockchain, usually by owning some of the cryptocurrency to be in, with a chance of selecting, verifying, and validating transactions. This saves substantial computing power resources because no mining is required. In addition, blockchain technologies have evolved to include smart contracts, which automatically execute transactions when certain conditions have been met. This was part 2 of Blockchain Explained. Have a nice day ahead. See you next week.